This is a demonstration of a capacitor-run induction motor. It runs from a single phase. So 120 volt supply comes in here from the wall. With only a single phase, an induction motor cannot start up itself. You don't have the rotating magnetic field like you would with a three-phase supply. So there are different ways in which you can get that torque that you need, that spinning magnetic field. And one way is by using a run capacitor. So the way this works is the AC supply comes in. In this case, I have it going through a fuse for safety. Then through a button, and then it branches off. There's two branches. One goes through these resistors. I have 8 10 ohm resistors in series for a total of 80 ohms. And then it goes through one of these coils and then through the other coil and back to the neutral. The other branch splits off and goes through these capacitors. Now I have 3 capacitors here because I needed a higher value than what I had available. So I connected the 3 capacitors in parallel to increase the total capacitance. After passing through this capacitor, the voltage on that branch is actually going to be shifted in time. A phase shift is what it's called. And in this case, it's not going to be completely 90 degrees out of phase. And it does depend on the speed of the motor. And also I have some other, with the resistors on this side, it's going to change how far out of phase branch 1 going through the resistors and branch 2 going through the capacitors is. But what we get from that shift in phase is we have basically a staggering of magnetic fields that happens in these coils. Because just like the other branch, this one goes through the capacitors, through this coil, and then through this coil. Here we have a rotor. And this is similar to what they call a squirrel cage rotor. It has no electrical connection. It has no magnets on it. In this case, it is a jar from a jam, is a lid from a jam jar. Strawberry jam, I think. I've heard marmalade has the best performance out of any spreadable condiment that you can get. But I don't really care for marmalade. It makes me sweat. So I just went with the strawberry jam jar. So the idea is I push this button. The 2 branches are going to have their alternating current flowing through the coils, and they're going to create somewhat of a changing magnetic field. The magnetic field is going to induce a current in the rotor. Having a current flowing in a conductor like this jam jar and having that be near a magnetic field creates a force. And so that causes that rotor, once the current starts flowing in it, to begin to spin as it is pushed away or pulled towards the magnetic field that's moving. Here we go. So it begins a little slowly, but then it quickly speeds up. And this rotor would eventually get close to what's called the synchronous speed which is the speed that the magnetic field is changing around in the stator. I will post a circuit diagram showing the different components and their values so that you can see how this was made and how it works. I'm actually really surprised that it spins. I was not expecting it to spin. It's nothing fancy. This jam jar is glued onto a caster wheel that I found in the parking lot. It spun fairly easily, so I just said, well, I'll use that. And otherwise, some bolts, magnet wire for wrapping these coils. About 200 turns on each. And then the resistors may be harder to come by because they dissipate quite a lot of power. So if you want to calculate it, it's about 1.5 amps flowing through this branch with a resistance of 10 ohms each. So these are rated for 25 watts, but they still get rather hot. One more time.